But let's talk about the first article, inspection reporting. So we're going to be able to extract specifications automatically using software. It's going to calculate the limits for us. We're going to get balloons on our drawing automatically. We're going to be able to populate the forms of our company's choice automatically. And we can even read in dimensional result data automatically. So let's give you a demonstration of the software. There are two pieces of software I'm going to show you. One will work with PDF files and TIFF files, typical of you receive a print from a customer, and you're going to take that print, which is the legal binding document for producing that part, and mark it up with the appropriate balloons and get the information from it. The second software will work on native CAD data, in this case SolidWorks, since most people have SolidWorks here, right? So this is a piece of software that you can purchase that will read in a PDF or a TIFF file. So I'm going to start with a new project and just, this project has some various settings, and it's going to ask me for a file to read in, a PDF or a TIFF file. So I'm going to go into my Enterprise PDM Vault as a quality engineer and browse in for a PDF file, this file that you see right here, this turned apart. So everybody can see that on their screen. PDF file is read in. It looks beautiful. This is the legal binding document that the customer has given us to make this part. All right. Now, the first thing that you might do when you look at this drawing is kind of identify it, right? You want to get the part number. You want to get a description, because you're going to have this information on the first article inspection form. Now let me show you what that first article inspection form looks like when it's done. So here's a form. This is the AS9102 format for aerospace parts. And you can see that we have a character number, a location, type of specification, what the value is, and then upper and lower limits that can be filled in, and the results. But here is a part number, the turn part. There's even 3 pages of this with multiple references to that information, as you can see right here. Let me close that out though. And let's start this one fresh. So we have a property manager on the left side of the screen, and it's asking us for the part name. So I could certainly type in what the part name is, but wouldn't it be cool if I could take this little camera with a rectangle next to it and draw a box around that right there? And you see what it's done? Look at that. It's highlighting over here in the part name. It has performed a recognition of the characters that it sees on that print. Now remember, a PDF file or a TIFF file is really just a collection of pixels. It's a digital piece of paper. There really isn't much intelligence in it. Now some PDF files can actually embed font information, and we can pick up on that as well. But even if this was just a scanned image and saved as a PDF, which is a typical process, you would be able to get an optical character recognition occurring and having it fill out this part name. Let's do it again for the part number. I'll hit the camera. I'll draw a box around that drawing number. And now in this case, you can see I've kind of went over some other information here. Because I had grid lines over it, it kind of had a little bit of a harder time. So I would help it out just a little bit. So you can always go ahead and adjust it if need be. This is especially important if you have a hand-drawn print. People are still making parts from 1960 for aerospace components, and they need to be, reports still need to be updated and created. So it's important to be able to have an override mechanism. Let's go ahead and get to the dimensional data. So I'm going to just zoom in slightly over here, roll in with my mouse, and look at our front view. And I have this 1/2 inch slot dimension right here that I want to call out. So I can extract a dimension. Just draw a box around it, just like that. we get a number 1 next to it for the balloon number. Let me just close that out of the way so we can see things a little better. And you see it's performed the recognition, half-inch dimension, plus or minus 5 thousandths. So it looked at the unless otherwise specified values, and I set that up in my project. And it's also calculated my upper and lower limits. Now in this case it's an easy, half-inch round number, plus or minus 5, and that's pretty easy to calculate in your head. But obviously if you're getting into more complex numbers, this comes in handy. It's doing it for you. It's saving work. Let's do this again for this 3/4 of an inch dimension with the plus or minus tolerance on it. And there it is. Now I might have missed the period in front of it, so I'll just type that in. But it's done all the rest of the work for us. Plus 4 minus 3, and calculated our upper and lower limit dimensions, which is important for the inspector who is actually taking the pair of calipers out and measuring it and validating it. Once again, we'll go to the 750 right here. Looking good. Now I might have just cropped that a little bit wrongly. So when you have this, I can just go in and window around what I'm looking for the nominal value, and there's 750. And then I can window around again just the plus or minus tolerance. Oh, picked the wrong one. Hold on. There's 750. And I'm just windowing it around here for the tolerance, plus or minus 10. Great. Now you can move these balloons around anytime you want. You can change the style of balloon. It doesn't have to be filled in. You can put a little leader line next to it, and things are going to be great. We'll just go around and pick a few more of these. That looks great. 30-degree dimension. I'm going to get to some of these more advanced things in a moment. 250. Might change some of my settings to see how it picks up on decimals because it's not picking them up for me right now. So there's many settings that you can look at. There's 938. If you want a geometric tolerance to be picked up on, just tell it that you're looking for that. So I want to window around this concentricity tolerance. It tells me to see the print for the geometric tolerance, but I could get into more detail. I could tell it, that this is indeed, a concentricity tolerance. It is 5 thousandths in diameter in concentricity. Just like that. And I can even window around the datum callout right here. There we are. And it gives us the upper limit. So life is good. You see what it's doing as we're working here. It's filling out the bill of characteristics at the bottom of the screen. Upper limit, lower limit, plus or minus tolerance. Everything's filled out, even the type of tolerance. There might be other things you might care about including when you're touching these dimensions. Perhaps it's the inspection method, the tooling that you're going to use to measure these dimensions. So let's say for all linear dimensions, and I'm going to sort this list by linear dimension. For all linear dimensions, I'm going to measure using a pair of digital calipers. For my diameter dimensions, let's pick another tool from the library here. And then for these two dimensions, I'll pick another method. So all that tooling can be customized to match what you have in your tool crib. You also have options for the type of ballooning. And as you pick on each dimension, you get good information here to comments, if it's key dimension. All that's right there. Now we're ready to go ahead and publish this information to a balloon drawing. So I can just spit out a PDF file of this document at any time. And I'm going to call this B, just so we have a separate file. And now we have a new PDF file with our balloons on our print. Now, of course, you want to take the extracted information and publish it to the form of your choice. So I'm going to hit the Excel button, and it gives me a list of different formats that I could publish to. I'll choose the PPAP form, and I'll export it. And now we have a new Excel file in PPAP format with the part number, description, the values right here, the date, I can actually place in there, and then the quantity tested, and then the actual measured results. So let me zoom in on this. This is just an Excel spreadsheet. So I'm going to say this came out to 0.501, and it evaluates to OK. Maybe I want this to be 0.378. That's OK. But if I make this 1.341, it's obviously not going to be OK. That's the second measured part. Now I'm typing in this information. You can actually have it just read in information from a pair of digital calipers as you're measuring parts. It'll link up to the spreadsheet. Or from your CMM, you can actually import this information as well in bulk and read it in to this Inspection Expert software that you see right here, and it will color code the dimensions on your page. So let's say the CMM evaluated this at 29.99 for this angle. This concentricity came out to 0.001, so we're really on target there. This was 0.751. So you see it's color coding the dimensions on our screen. Let me sort by balloon number. Now if I make something out of spec, it's going to make it red, of course. So that's for measurement 1. But I can add multiple measurements. And if I had a CMM, it would might have 50 different parts being measured if you're measuring all your parts. So this isn't the only type of export you get. You get export that can be formatted in many other formats other than Excel. You might want to publish it in a format that can be read into a quality tracking software as well. So that can also be accomplished.